In this lesson, we'll conclude a review of Reading Test 7, Section 1. We are on the fifth and final passage, how the Higgs boson was found. And we did the first part of this passage in the last video, and so we are now on question number 48. And so again, this was the Higgs boson. In the beginning, explained the theory, described the inconsistency, and then how the scientific community at first didn't accept this, and then gradually it was. So let's take a look at number 48. Which statement best describes the technique the author uses to advance the main point of the last paragraph? So we have some direction here. It's a specific question. We want to know what technique the author uses to advance the point of the last paragraph. So let's take a look. The last paragraph, it's here. While I wasn't around to witness the initial rejection of the Higgs proposal in 1964, well, I was around, but only barely. I can attest that by the mid-1980s, the assessment had changed. The physics community had, for the most part, fully bought into the idea that there was Higgs field permeating space. And so he's giving sort of a personal anecdote, right? I personally wasn't around, but by the 80s, I can attest that it had been accepted. In fact, in graduate school, I covered what's known as the standard model of particle physics, assembled to describe the particles of matter and the dominant forces. The professor presented the Higgs field with such certainty for a long while, I had no idea it had yet to be established experimentally. And so he's given this personal example, this anecdote, and he says, the professor presented it, and he had no idea it had yet to be established. And then the final sentence here, on occasion that happens in physics. Mathematical equations can sometimes tell such a convincing tale, they can seemingly radiate reality so strongly that become entrenched in the vernacular of working physicists even before there's data to confirm them. So this is sort of like an anomaly. This doesn't happen in science. Usually you need the data to validate the theory and then it's accepted. Here it was so powerful, it was actually accepted before. And he also uses a personal experience to relate that. And so let's take a look at 48. We want how the technique he used. A, he recounts a personal experience to illustrate a characteristic of the discipline of physics. This is exactly right. It's his own personal experience and also how things work in science. All right, let's take a look at question number 49. This is a vocab in context. In line 77, what does established mean? So we're just going to predict in 77 what established means. And this is the sentence, the paragraph we just read. The professor presented the Higgs field with such certainty for a long time, I had no idea it had yet to be established experimentally. So established means proven here, right? This is the theory. He didn't know that it had yet to be proven with data. And what's another word for proven? It's validated, right? Validated or confirmed. The answer is A. And let's take a look. We've got a few more questions. Number 50, remember there's a graph here. There are 3 questions. So question 50, what purpose does the graph serve in relation to the passage as a whole? So let's take a look at the passage as a whole and the graph. And you see, remember the passage was about the Higgs boson. And we've got this time frame. And it says years from the introduction of the concept of particle to the experimental confirmation. So you see, this was back in the early 60s when Higgs presented this, but it wasn't confirmed until the end. And remember in the reference information at the very top of the passage, it said it wasn't here. Conducted, tentatively confirmed the existence. It wasn't until 2012 and 13, even though it was introduced in the 60s, so that's kind of a big time frame. But if you look, there's all these other particles as well, right? And so let's take a look at the answer choices to help us out for 50. What purpose does the graph serve? It indicates the scientific community's quick acceptance of the Higgs boson was typical. We know it wasn't quick. It places the discussion of the reception of the Higgs boson into broader scientific context because those other particles are compared. This is definitely the choice. All right, last 2 questions, 51 and 2. Which statement is best supported by the data in the graph? So let's take a look at the graph again, and then we'll look at the answer. So again, the data in the graph, different time periods from when it was first introduced to when it was accepted. You kind of have to cull through these to find the answer. Let's take a look at A. The W boson and the Z boson were proposed and experimentally confirmed about the same time. So let's just check to see if that's right. W and Z proposed and confirmed about the same time. Let's see. All right, so here's the W, here's the Z. Introduced, well, confirmed. That definitely is right. We can just stop right there. That is definitely right. Introduced and confirmed at the same time. So the answer is A for 51. And let's take a look at the last question. 52. Based on the graph, the author's depiction of the Higgs theory in the mid-80s is most analogous to which hypothetical situation? You don't see this question too much in the reading. So they're giving just a different set of facts, and you have to see which is the closest analogy to the Higgs theory in the mid-80s. Let's take a look at the Higgs theory in the 80s first, and that might help. So the Higgs theory in the 80s, okay, it's on the bottom here. So we know it was first introduced in the early 60s, but in the mid-80s, that's sort of like in the midpoint between when it was introduced. This is a long period too, and when it was confirmed in 2012. And so that's right in the middle. So let's see if we can find something analogous to that. All right, so number 52, the muon neutrino was widely disputed until being confirmed in the early 60s. Now again, even though this looks right, because we know that the Higgs boson wasn't accepted, we want the mid-80s. So let's take a look at the muon neutrino in the early 60s. Let's see, it's kind of tough because we have to go back and forth here. So it's this one and early 60s. No, that's not right, because early 60s is when it was confirmed, right? That's not analogous to the midpoint of the Higgs boson. So it's not A. And let's take a look at B. Few physicists in 2012 doubted the reality of the tan neutrino. Let's just keep looking at these. No physicist prior to 1960 considered the possibility of the W or the Z. Again, the key here is it's the mid-80s, the most analogous. And so we know the mid-80s, and I would try to make a prediction here, is sort of the midpoint of this long period between when it was introduced and when it was finally confirmed. So you're looking for something about that time period relating to another particle. How about D? Most physicists in 1940 believed in the existence of the electron neutrino. So the 1940, the electron neutrino. And see, here's the electron neutrino. And that is sort of, if they're saying most believed, remember, this kind of relates to the passage. Remember, the author was using that personal anecdote about the mid-80s, and it's this last paragraph here. I can attest by the mid-80s, the assessment had changed. The community had, for the most part, bought into the idea. So we know that even though it wasn't proven until 2012, the Higgs boson was readily accepted, even though that's very unusual in science. And now they're giving us an analogous situation with the electron neutrino, that in the middle of the period between when it was first proposed and when it was accepted, the question says that most physicists believe in it. That would be analogous because we had that personal account from the author. All right, and so the answer here is D.